Hi, I'm Carl, and in this video we're going to go over questions 26 to 28 of section 3 of the orange booklet. So this is a question about mass numbers and atomic numbers. Just a quick revision of what they are. An atomic number is the number of protons in the atom, and then the mass number is the number of protons plus the number of neutrons. We're told here that there's this thing called NMR, nuclear magnetic resonance, and we're given a few rules here. So I think it'd be good just to start off with making a table of when NMR happens and when it doesn't. So we're told that all nuclei with an odd mass number exhibit NMR. And of course it wouldn't matter what the atomic number in this case is. But we're also told that if they have an even mass number and an odd atomic number, they will have NMR as well. And finally, we're told that nuclei having both even mass numbers and even atomic numbers do not exhibit NMR. So they're the rules that we've got in place, and let's go through the questions now. So question 26 says of the three isotopes of hydrogen, those that exhibit NMR are what? So we're given these three isotopes. We've got them here. This number here on the top left of each of the hydrogens here is the mass number. So remember, that's going to be the number of protons and neutrons. Going through each of the isotopes then, let's work out from our rules here which ones have NMR. So with this first one, we've got an odd mass number, so we know straight away that it's going to exhibit NMR. And the same is true for this hydrogen 3. And what about this here? So we need to remember that the mass number is going to be the number of protons and neutrons. Atoms are defined by their atomic number and their isotope is defined by their mass number. So the thing that might change is the number of neutrons. So here, if it's going to be hydrogen with with a mass number of 2, it's going to have 1 proton and 1 neutron. They're both going to be odd, and so we're going to get NMR in this case too. So if all 3 of them demonstrate NMR, then the answer for number 26 is going to be D. If we move on to question 27, then it says, in which of the following lists does NMR occur in all of the nuclei? So again, we've got our rules here, and we can just apply these to our different lists, but it might be worth just having a look straight away to see if there's any we can eliminate off the bat. So the atomic number for helium is 2. It's got 2 protons. And so we know that if it has an even atomic number, it can't have an even mass number if it's going to exhibit NMR. So that means we can rule out A straight away by looking at the first one. What about B? So we've got helium 3. It's got an odd mass number, and so we know that it's going to exhibit NMR. If we look at nitrogen, then it's got an even mass number. But what about its atomic number? Well, the atomic number for nitrogen is 7. And so because it has an odd atomic number, we're going to be looking at this line here. It is going to still exhibit NMR, so we can tick that one off too. If we look at fluorine, then this is fluorine 19. It's got an odd mass number, so we know it's going to exhibit NMR. And then finally we've got phosphorus 31. Again, 31's odd, so we know we're going to get NMR. So that means this list, all of these isotopes exhibit NMR. So the answer for this one is B, without having to check the others. If we look finally then at question 28, says the number of neutrons in the nucleus of an atom in which NMR occurs is always what? Okay, so we need to remember that the atomic number, or AN, is going to be the number of protons. The number of neutrons plus the number of protons is going to be the mass number, or Mn. If either of these are odd, then that's the circumstance under which we get NMR occurring. So either we have an odd number of protons or an odd number of neutrons. If they were both even, then by this third rule at the bottom here, we can see that it wouldn't demonstrate NMR. So if one of them is odd, then it's fine. So if we were to have a look at option A, then it says the number of neutrons in the nucleus of an atom in which NMR occurs is always A, odd. Well, if you had the odd number of neutrons but an even number of protons, then you'd end up with an odd mass number, so that would be true. But if we were to look at B, then it says, what if the number of neutrons was even? If you had an even number of neutrons and an even number of protons, then you'd have an even mass number, and that wouldn't work. C says odd if the number of protons is even, and from what I've drawn here, we can see that one of them has to be odd, and if the number of protons is even, in order to get an odd mass number overall, you would need the number of neutrons to be odd. So the answer for this one is going to be C. But to rule out D, say even if the number of protons is odd. If the number of protons is odd, NMR will occur anyway. We're told that if the atomic number is odd, which is of course the number of protons, is going to demonstrate NMR anyway, so it doesn't matter, so it'll end up being C for this. So that was questions 26 to 28. I hope that helped. Thanks for watching.